going to go ahead and start just because we have a lot of material. Again, anytime through this workshop, feel free to post a question, and I'll be happy to stop and check it out with you. Cool. And Edward says other projects are using Datadog and Zipkin. Yeah, Datadog is actually part of the OpenTelemetry collective. So they're you can use OpenTelemetry with Datadog, by the way. Zipkin is another tracing system, and yes, OpenTelemetry and Zipkin can interact. You do want, ideally, to be sending all of your data to the same place in the end, but it is possible to interact with Zipkin and OpenTelemetry and run them both in the same system. But again, you need to have all of the data going to the same backend. So you'd want to run your OpenTelemetry configured to use a Zipkin backend, but that would allow you to switch over to OpenTelemetry on the client side is like a way to kind of get started there. All right. Yeah, you're welcome. Okay, so let's get started. Again, another just ask. If you wouldn't mind creating a Lightstep account, that'd be super awesome. Check it out. But let's get started with OpenTelemetry. So what actually is OpenTelemetry? There's a good question as to what part of the observability stack that OpenTelemetry fills. It fills a particular portion of it. And it's right there in the name, telemetry. So telemetry is the process of actually collecting information and transmitting it to a faraway receiver that's actually going to process the information. And that really defines the part that OpenTelemetry plays in the observability system. We see OpenTelemetry as a standardization project. The goal of the project is to come up with a shared language for describing distributed systems and cloud systems, web systems, any kind of computer system, so that you can look at this data and not have to know too many details about the systems that we're sending it. In the past, you kind of had the tools that were collecting the data tied to a particular data processor in the back end. And with OpenTelemetry, we want to have a more neutral way of going about that. And the hope there is to allow libraries and frameworks and other pieces of open source software to be able to embed OpenTelemetry directly in them and be able to describe what their system is doing, rather than having third parties have to come in and instrument them as an outsider. So that's kind of one of the goals of the project, and it sort of defines the scope of the project, which is just the creation and the sending of the data. And we'll go over that a bit more as we walk through this. So one way I like to start describing OpenTelemetry to people is just to describe the pieces of the telemetry system that OpenTelemetry provides. It's good to know these main pieces because OpenTelemetry is divided up a little bit more than other systems might be. So when you see OpenTelemetry, you might see some words flying around like API and SDK. So let's just dive into that and explain the major pieces that you would install if you're going to use OpenTelemetry in your system. So the first piece you want to install is the SDK. So this is basically the OpenTelemetry client. So if you're going to get data out of a particular service, you do need to have the OpenTelemetry client embedded in that service. The client's divided into two parts, the API and the SDK. The SDK portion is the actual implementation. So it's a framework implementation. It has all of the kind of plugins and lifecycle hooks you would expect. So it has exporters that allows it to talk to different kinds of backends. It has interceptors so that you can intercept the traces being generated and do something useful with them and process your data. It's also where you put in all of your configuration. So the way this works is you install the SDK, you configure it how you want, or you install a distro of OpenTelemetry that's already pre-configured. Most of the configuration you have to do is setting it up to talk to a particular backend. So Lightstep, for example, has a distro called the OpenTelemetry launchers, and that's just the OpenTelemetry SDK, but just wrapped up with some configuration so that it's already configured to talk to Lightstep. AWS has a distro as well. You'll probably see distros coming from other providers, and that just kind of saves you some configuration time. But it's important to note that you don't want to be using the SDK directly in your instrumentation. The SDK is just for setup and teardown. So it's just how you configure OpenTelemetry. And we've actually decoupled the API entirely from the implementation. So this is sort of a loose coupling between systems approach. When you actually go to instrument your library or your application, you use the API packages. So the API packages contain no implementation. They just contain the interfaces and constants and other things you would access directly when you're instrumenting your code. And that clean separation has a couple of advantages. One, it means if you pull in the API, you're not automatically pulling in a big dependency chain, right? The SDK is going to have a bunch of dependencies. It might have a dependency on gRPC, depending on how you've configured it. But you don't automatically pull any of that in just by pulling in the API. So this makes OpenTelemetry safe to be embedded in shared libraries. So you could instrument, say, your web framework, like an open source web framework could instrument itself natively with the OpenTelemetry API, and then a database client could instrument with the API. And then when you, the application developer, pull those components in, there's not having any kind of dependency conflicts or defining anything. So all of the libraries that use instrumentation use the API, and then you, the application owner, install the SDK. And the API can actually be bound to a couple of different implementations. So the SDK is the default production implementation we provide people. But if you don't install an SDK, then the API comes with a no-op implementation. So those instrumentation calls will just do nothing and produce no overhead. And we also have in every language like a mock or a test implementation. So if you're testing and you want to confirm that your components are producing spans and events properly, if you want to actually test your observability, which I suggest doing. In the past, people say don't test your logs. I kind of think it's important to verify at least some basics about observability and to a certain degree tie your runtime observability to your tests and development. You want to make sure that those things are actually kind of coherent and related to each other. So you can use the mock implementation in your testing environment. So again, this is I think just a sort of a repeat of what I just said. The way it works is you've got your frameworks, your HTTP client, your SQL client. They take the API, they add a bunch of instrumentation calls into them, and all of that is just talking to the API, which sits in front of the SDK. So you don't ever have to reference the SDK when you're instrumenting your app. The next important piece of OpenTelemetry is the collector. So the collector is a separate service. It's written in Go, and you can run the collector as a sidecar or in your local network, your VPN. You can use it as a gateway, and it's a telemetry processor. So it takes all of the telemetry data being produced by your system, so that spans, metrics, logs. It gives you a place to buffer that information and a place to do a lot of the configuration, and then process that data, manipulate it, scrub it, and then send it on to whatever backend you want to talk to. And one thing I recommend doing with the collectors is to move a lot of your configuration to the collectors. So rather than install a bunch of exporters or trying to make your clients talk directly to your backend, you leave your clients in more of a default mode and have them talk to a collector. you could even be just talking to local hosts and running a collector as a sidecar. And the advantage of that is when you're reconfiguring your telemetry pipeline, if you want to change where the data is going or how it works, you're just redeploying the collectors versus having to make a code change or a configuration change to your app and then redeploy your app. So when you do run OpenTelemetry, I do suggest having a look at the collector. And when you go to run OpenTelemetry in production, consider using the collector not just as a way to buffer and process data, but also as a way to allow you to control the configuration of your telemetry pipeline in such a way that you don't have to be redeploying your apps if you want to be changing how that works. So that would be, say, where you would put your configuration to send the data to Zipkin versus sending the data to Datadog or Lightstep or some other backend. And you can even tee the data off and send it to multiple backends at the same time. The collector has plugins for a lot of common protocols and backends. And like I just said, you can send it, say, send your metrics off to a Prometheus backend and then your traces off to a Zipkin backend. So it's a really flexible tool. I recommend checking that part out. As far as backends goes, OpenTelemetry doesn't provide its own backend. So there's no analysis tool that comes with OpenTelemetry. There are open source projects that are kind of OpenTelemetry native. Jaeger is a good example of that. So Jaeger's an open source tracing system that comes with its own backend. But the OpenTelemetry project itself doesn't provide one because we don't really see analyzing the data as something you want to standardize. That's actually where all of the innovation and competition is happening right now. What we're trying to do with OpenTelemetry is standardize the data that these systems are looking at so they can start having better expectations of what kind of data they're going to receive. So for example, we have standard conventions for how to describe an HTTP request or a database call. And that allows these systems, when they see the data, to actually know, oh, this is an HTTP request, as opposed to just, say, sending logs to a logging system where the logging system doesn't actually know what the data is that it's looking at. So in other words, we're not just trying to standardize the syntax, we're also trying to standardize the semantics or the meaning of the data for common operations and common things that people might see. Of course, your application is going to have its own data that's going to be unique to it. Though I do recommend in your organization, you start to kind of come up with your own standards and semantics for how you report that data, because that'll make it easier to generate dashboards and things like that when you start spinning up new services. The more conventions you have, the easier it is to kind of automate these systems and automate the analysis that's going on in these systems, which is another area that's, I think, really interesting and hopeful. You'll see this called like AI ops or something like that. I don't really like that framing of it, but I do like the framing of having the system save you a lot of work. So stuff you would have to do by hand, being able to automate it because the data is standardized. That's one of the exciting things we're starting to see people do with OpenTelemetry. A quick note about how the project itself is structured. In order to keep all of this stuff across all of these different languages kind of in sync with each other, we have a specification process. So if you go to our GitHub, OpenTelemetry, you'll see there's a specification repo. And that's where we define how the clients work, how our protocols work, and things of that nature. So we have an RFC process. People write RFCs. We call them OTEPs. And when those OTEPs get approved by the technical committee, they then get added to the specification. And then we cut a release of the specification, and the maintainers of different language clients and the collector implement the latest version. So that's sort of the process that we go through to actually drive OpenTelemetry forwards. And it's a completely open process. So anyone can write an OTEP or contribute to the spec. Likewise, it's open source, so anyone's able to join one of the language groups. So you could join the PHP group. There's a weekly meeting where you can say hi and ask questions. You can also say hi on Gitter, where we currently hang out. But I think we're going to change to Slack soon. We're getting pretty sick of Gitter. So that's the basic process for how we develop the project internally. We also have a community repo that contains some of these basics where you can go find where all the meetings are happening and things like that. So if you're interested in joining the project, maybe contributing instrumentation or anything like that, start by looking at the community repo in our GitHub. That'll give you pointers to where to go. And it's a very friendly community. The maintainers are very approachable. You know, I know a lot of the Python maintainers, and they're all great people. So don't be afraid to join our chat room and ask questions there. Okay, that's everything for the basic design of the project. We're going to move on at this point to sort of talking about distributed tracing, which is the core of OpenTelemetry and sort of what differentiates it from like traditional metrics and logging systems. And we're going to talk a bit about the fundamentals behind distributed tracing, because while you may not have to interact with this stuff directly when you're instrumenting your app, it is good to have some of this in the back of your head. And since distributed tracing is kind of new or novel to a lot of developers, I just want to spend a bit of time describing how that works and the value that it provides. So the core behind distributed tracing is the ability to trace or view a transaction. So what is a transaction? And I should emphasize these are distributed transactions. So what is a distributed transaction? Well, that's really any kind of web request. But as we know, web requests are often not just a single request. So if we walk through a super basic example, imagine we have a mobile client that wants to send a photo and a caption to a backend service to be stored. So it's just a super basic photo app. How would that work? Well, the client would talk to a server, upload the photo and the caption, right? But it's never that simple. And honestly, it never was that simple, even in the days of monoliths, right? At minimum, you know, you have a proxy, you probably have an authentication system that's separate. So that client would talk to the proxy would then go talk to an authentication server, make sure you're valid. If that checks out, the proxy might upload that image temporarily to some kind of scratch disk and then send it on to your application to process. But even your application itself is talking to other systems. For example, it might then upload that photo to some cloud storage system like S3, and then take the caption and the URL of the image and upload it to a data storage system. And that might be its own service, which is sitting in front of a couple of other services. For example, a caching service written in Redis or Memcache, and then an actual a database such as, you know, SQL flavor of some kind. So this is like, to my mind, a really traditional simple app. And you can see that even traditional simple apps had a whole bunch of components. There were a whole bunch of services. And observing this transaction, actually pulling this transaction out of your logs and out of your metrics, has always been a little difficult to do. And it only gets worse as your systems scale up. So, you know, once your system starts looking like this, you start throwing in serverless and some of these other things, it starts to get really crazy. And it becomes really difficult to even find your logs. So one of the most basic things you want to do when you're observing your system is just see all the logs that were in that particular transaction. But if you're using traditional tools that don't have distributed tracing as a component, just think about how much time and effort you spend collecting and then sort of searching and filtering that data down whenever you want to see a transaction. You have lots of different servers. They all have the logs stuck on them. And those logs are intermixed with logs from all the other transactions being processed through those servers. You might be sending all those logs off to a backend database that can index them. But what index do you have to just find the logs in a transaction? And being able to provide that index, that transaction ID, is kind of the core of distributed tracing. Because if you don't have that one ID attached to every log, it's sort of a hunt you have to do. You can maybe find a request ID here and find some logs associated with that, and then maybe find another piece of the puzzle, search for some more logs. It actually can take a fair amount of time to reconstruct a trace of the system. So people got sick of having to do all that work by hand, including myself, and we started switching to distributed tracing as a way to solve that issue. So distributed tracing is basically a process of being able to take a single ID or a bag of IDs and pass it around through your system so that you have that ID accessible every time you make a log or you make a metric. So that's distributed tracing. But OpenTelemetry isn't just tracing, it's also metrics and eventually traditional logs as well. And that's because you have this other issue, which is connecting up your aggregates, your dashboards, with the actual events that are causing them. So this is like a classic thing that you do. You have some dashboard, you have an alert set when some value goes beyond a certain range, like say error rate or something. And let's say you see a spike. So that's great, but the next question you're going to ask is like, well, show me the transactions that are generating this data. And that itself is a hunt where you have to spend a fair amount of time actually tracking things down and trying to verify that these logs and transactions you're looking at are related to these errors being generated or whatever else it is in one of your dashboards. Now you can do it, we all do it, but you might notice that it's just time spent. And if you could automate all of that away, then you could spend all of your time just analyzing the data. And if you could move around through this data easily, if every time you saw a dashboard, you could get example transactions that were related to that. And then when you were looking at your transactions, be able to relate those back to your dashboards, that would just be really helpful. And it is really helpful. The faster you can move, the faster you can iterate, the faster you can investigate hypothesis. And that alone is a big step up. So OpenTelemetry provides that by kind of gluing all of these different observability tools into a single system. So tracing is the most stable portion of OpenTelemetry. Metrics are coming soon as an experimental feature. We hope that metrics will be stable by, say, midsummer. And we're also starting to do a lot of log processing. So the OpenTelemetry collector is turning into a log processor so that it can process, standard traditional logs coming out of your system. But we also have tools that will allow you to translate your logs into tracing data and take those trace IDs and attach them to your traditional logs. So that's just ways to make all of these different tools a little more valuable by having the right indexes and correlations available on them. So one more walkthrough, if we're talking about distributed tracing, if you've got a system that kind of looks like this is sort of a service map view of the system. And that's helpful, but when you start looking at tracing, you'll notice you'll start to see diagrams that look like this. So I just want to do a quick explanation for what these trace diagrams tend to represent. So in this case, it's color coordinated. So each one of these spans here represents an operation and a service. So this is our client span. This is our proxy span. This is our authentication server span. This is the uploading the image to scratch disk span, app span, yada, yada, yada. So this is actually sort of like a flame graph, and it has a lot more data in it when you're trying to analyze a particular transaction. It's one thing to just look through this data as like logs and events, but this kind of visual graphic allows certain things to really pop out at you. In particular, issues around latency. So the length of each one of these spans represents how long that operation took, and the arrows represent network calls and where the network calls happened. So you can see in a system like this, where is the time going? So in this case, sorry, I should back up and say, when you look at this kind of critical path, this is what we call a critical path. The client span is the span that took the longest because it was open for the entire length of the transaction, but it was spending a good chunk of its time waiting for these other services to perform work. So if you're trying to optimize this system, you need to understand where the work is actually being performed and which one of those operations is contributing the most to the overall latency. And this is the kind of automation that you can get once you start having standard data and things like tracing. So Lightstep, for example, has a critical path tool that will automatically identify this stuff for you. And a lot of other systems are developing similar kinds of tools. And this is really useful. For example, maybe you were looking at your data service and we're trying to figure out how can I optimize this database and make it work faster. But if you look at a trace like this, you quickly realize that optimizing this data service isn't really going to move the needle very much. All of the time is actually being spent uploading the image to scratch this and then to cloud storage. So if you want to optimize this transaction, you really need to be focusing your efforts on, image processing and image uploading. And this is the kind of stuff that will just jump out at you if you're looking at your transactions in a graph like this. You can also see when your systems are sitting there waiting, and if you're using systems that where blocking might be an issue, in Python, you can have issues where something's being blocked. That kind of blocking will also pop out at you. Likewise, you can see places where things are happening in serial where they could be happening in parallel, or you thought they were happening in parallel. So when you first turn on a tracing system, this kind of latency information can usually earn you some quick wins. Because if you haven't looked at your data like this before, certain latency errors or serialization versus parallelization errors kind of leap out at you. Speaking of errors, you also want to know where a problem is coming from. And these kinds of graphs will quickly be able to identify which service was actually generating the error. And that can be really helpful. Since you have this whole data connected in a graph, maybe the initial error you were receiving was like an air brake error from your mobile client, where you were getting 500s from that. You could start with that error and then pivot to tracing and see that the root of that error was actually coming from, say, the authentication server. So that's a way to kind of quickly hone in on where the problems are actually being generated, starting from where you first get the report of an error resulting. So that's another useful thing you can do with tracing, just which one of these services is actually generating the error. Last but not least, these operations, these spans are kind of coarse-grained, but I do want to emphasize that tracing also includes logging. It's called trace events, but it's basically structured logging, only now all of your logs are contextualized by this trace information. So one thing I really recommend when people get started with tracing, if you already have logs in your system that you're happy with, you can write a converter that intercepts those logs calls and adds them to your trace. So that's a useful way to quickly add a lot of information to your trace. And you might find over time, once you've got all of that information in your tracing system, that becomes sort of the first place you look, and you may end up not actually looking at your logging system all that much if you can get all of that data into your tracing system. Some tools like Zipkin have, because I saw someone was using Zipkin. I should mention some of those tools have a sort of basic approach to sampling, where it's only on, say, 1 out of 1024 requests. And it's definitely true that a tracing system that has that kind of sampling, where it's off most of the time and it's just rarely sampling, that wouldn't be all that great for replacing logging and other kinds of tools, because you're going to miss important errors and events and things like that. But I want to emphasize that that's sort of distributed tracing is moving away from that approach to sampling. And so more modern systems like Lightstep and others don't use what's called upfront sampling. Instead, they collect all of the data and they do sampling on the back end. So that sampling will save you money because you're not storing all the information, but it's heavily weighted towards saving anomalous information and errors and things of that nature. So you'll find you have kind of this good middle ground where you're not saving all of your logs in a logging database where it's really expensive, and you're not using a distributed tracing tool where it's just running some of the time, so you're missing errors. More modern systems are kind of splitting the middle with more advanced sampling algorithms. So I do want to mention that, because if you're used to thinking of distributed tracing in terms of Zipkin, then some of what I'm saying here might not make sense. But Zipkin's just got a particular old school form of sampling that you don't have to worry about anymore. So last but not least, you want to be able to start looking at these traces and transactions in aggregate. You don't want to just be able to connect all of these events together within a transaction. You also want to be able to connect across transactions. So you want to know all of the transactions coming out of a particular host or region or a particular library. And distributed tracing gives you all of those correlations as well. So each one of these spans can have attributes added to it, and those attributes work as indexes that allow you to find these spans in your system later. So when we get to the code walkthrough portion of this, I'll show you how to add all of this information using OpenTelemetry. Okay, we're going to dive into context propagation next, but I do want to stop and just ask if people have any questions at this point. You can either raise your hand, and I'll, using the raise your hand tool in Zoom, you can find that on your Zoom bar, and then I can turn your microphone on, or just you can type your question into the chat and I'll answer it there. Okay. Well, I don't see any hands raised, so I'm going to move on. But you can continue to post in the chat, and I'll get back to it in a minute. Okay, so context propagation. Been talking about the value of distributed tracing and talking about what you can get out of these traces by having all of these indexes. But there's an aspect of actually making that work that I think is important to know. And that's called context propagation, which is how you actually take some of these indexes and attributes like a trace ID and a span ID, maybe a project ID or an account ID, and be able to propagate them through your system. And so the way that works in OpenTelemetry, let's imagine you have a client and a server, and then you have a number of operations in the client, and then a network call to the server. So there's two portions. One is what we call context. So context is a way of being able to track the execution of code within a process. So some languages like Go have an explicit context object. Python has a context concept as well, context vars. In some languages, you can use things like thread locals to store this information. So OpenTelemetry has a context object that will sort of wrap whatever the native mechanism is in that language to propagate information down the stack. And what this allows you to do is pass around things like trace and span IDs without having to like add them as parameters to every method call. Instead, it's all kind of available to you in the background. And when you hit a network call, though, you need to take that context and somehow hop over to the next system with that. And we call that portion propagation. So propagators are a set of HTTP headers, for example, if you're using HTTP, or like Kafka metadata, someplace to stick this information in the network request. And so when your network request begins on the client, you inject that information by, say, writing it out into a set of headers. And then on the server side, the tracing system inspects your network, the incoming request. And if it sees these headers, it'll deserialize them and form a new context object that allows your context to continue propagating. So that term context propagation, you might hear that in OpenTelemetry. This is what it's talking about. It's sort of the fundamental that everything is built on top of. And you yourself, probably as an application developer, won't have to interact with it directly because you'll be interacting with these tools that are kind of higher level. But it is important to note that you do have to have your propagation settings set the same between all of your systems. There's a couple of different headers that you could use to propagate this information. For example, Zipkin has a set of headers called B3 headers that system uses to send tracing information. We've been working with the W3C to actually create a standard set of headers called trace context headers. And so we're hoping that standardization will start to make these headers more common and avoid issues where you have a header mismatch. So for the person who is asking about integrating OpenTelemetry with Zipkin, you would want to make sure that you've configured your OpenTelemetry clients to use B3 headers. Otherwise, you'll have a mismatch and then you'll have broken context propagation. So that's like a fairly common gotcha. If you're just using OpenTelemetry out of the box with the defaults, you won't run into it. But if you're running a mixed system, that's one of the things you want to make sure you get right. And just real quick, having a look at these tracing headers themselves. They're not really complicated. So the trace context header has two headers. There's a trace parent header and a trace state header. The trace parent header contains your trace ID, which is a 128-bit random value, a span ID representing the ID of the parent operation. That's a 64-bit value, and just a sampling flag for systems that use the more Zipkin old school style of sampling. So this is kind of how you can connect the graph up. You get a trace parent, so you know your trace ID, and then you also know the operation on the client side that was calling you. So when you create your span to measure your operation on the server, you create a new span ID and you set this client ID as your parent. And that's how you connect the graph together on the back end. All of these systems, you could think of it as like every log that comes out of your system will have a trace ID and a span ID on it. So you can index them in your database. There's also some trace state where systems can put some internal details. And another set of headers called baggage headers, which is where you as the end user can add your own data. So people aren't making a lot of use of this yet, but I do think it's going to be helpful in the future. And this is basically, once you have distributed tracing in place and you're propagating this context, you might find other reasons to use it outside of observability. For example, A/B testing. You might have the A path and the B path. And in a distributed system, each service down the line needs to know whether it's in the A path or the B path. So you could just use baggage to say, hey, this is A path or this is B path. And then that baggage would get propagated to all of your services in the transaction. So I think a tool like baggage will make things like A/B testing a a lot easier to do as systems get bigger. Okay. So that was all a mouthful, but that's all of the theoretical stuff that we're going to go over this workshop. At this point, I want to just switch over to a code walkthrough to kind of show some of this in Python. And I think I said on the invite, Django. We do have some Django examples, but the one that I have is in Flask. So I'm just going to use this one because it's what I have. But I do want to point out, if you are interested in Django, OpenTelemetry comes with a Django example baked into the documentation in the repo. Oh wait, actually it's the auto instrumentation. Sorry about that. Here you go. This is the right line. So if you are setting up a Django app specifically, you can use this tutorial to walk through and add OpenTelemetry to it. What I want to go over, though, is just the basics of how you would set OpenTelemetry up in Python. So let's say you have a super basic Python app. You've got just a client and a server. The server just serves up hello world. And the client just makes a request to that. Super basic, super basic. So I've got this set up on my local. So start it and stop it again. And so I'm going to start my server here. And then I'm going to run this client against it. That should make a bunch of requests in a loop. There you go. And now I'm going to just look at this data real quick in Lightstep. So here we can see those spans coming in. And if I look at one of these, we can see one of these traces. So we've got a couple of spans on the client side. This one here is coming from the requests library. So requests gets auto-instrumented if you have it installed. This span here on the server comes from Flask. And then this is just a span I've added manually. I'm going to show you how to walk through and do all of these things yourself. Here, let me make some room on the screen. Okay. So let's look real quick at the information that you get, though. So if you look at this server span coming from Flask, you can see there's a bunch of information that's already added to it around HTTP, networking, etc. And you can use this information to hop around. So for example, if I wanted to find other operations that were targeting this hello path, I could do a search, and then I can see that other operation, and then I can pop into that, and I can see the transaction that operation was part of. So this is a really helpful way to kind of hop around and use OpenTelemetry. Likewise, you could search by status code or any information you wanted to add to this. So that's a really useful tool. And here you can also see the critical path I was talking about. So that's what this black line is, letting you know which spans were waiting on another operation versus the spans that were actually performing the work. So let's have a look at how you actually set this up. If you're using OpenTelemetry in Python, the OpenTelemetry Python comes with some helpful tools. One of them is called OpenTelemetry Bootstrap. And what that will do is that will actually just look through your application and find all of the libraries that we have instrumentation for. So in this case, it's found Flask, SQLite, gRPC, requests, etc. So that's it. Because it's important to actually have your network clients in particular instrumented, as well as your frameworks. You want to make sure you actually install all of this instrumentation. And you can either install it by hand, the usual way, by just pip installing it, or you can have the Bootstrap tool do it for you. So install -A. So that'll actually install it all for you. Then when you start your application, you can do one of two things. You can either manually install OpenTelemetry and manually set up and configure all of these plugins. That's pretty straightforward. If I just show you the code here, the flavor of OpenTelemetry I'm using in this example is the Lightstep launcher, which again is just a little configuration wrapper. But this is about all you really have to do. Is just put in configure OpenTelemetry, plus configuring any of the plugins that you've installed. If the plugins are loaded, they should automatically bind to their targets. But you might want to look at the instructions for every plugin. I can show you where they live here. So they all live in Python contrib instrumentation. So here you can find all the plugins. And if there's any setup or configuration, you can find it here. So let me send you guys that link. However, there's also an automatic way to do that, which is just to use the OpenTelemetry instrument command line argument. So this will auto instrument your code. So if you use OpenTelemetry instrument and then, run your application. So let's see, server. Adding OpenTelemetry instrument as a wrapper around whatever your startup command is will automatically do all of this setup for you. So that's another approach. If you're just getting started, I would say out of the box, try to use OpenTelemetry Bootstrap to install the dependencies, and then use OpenTelemetry instrument to actually get them running in your system. And you can find some more detailed instructions for doing that. Here, let me find you the tab. Yeah, here you go. So our launchers will give you all of this setup instruction as well. So let me send you this. And you can also find this information in the Getting Started guide. So if you're trying to add OpenTelemetry to your system, this is just a useful place to look to find out where all the configuration options are. Okay. So that'll get you rolling. And what that lets you do is automatically create spans for anything that has instrumentation for it. So you can see here, the request library is automatically instrumented, and the Flask application is automatically instrumented. And that means two things. It means you're going to get a span covering that operation. It means context is also going to be propagated. So that means within your service, you're going to have access to that span if you want to decorate it with additional information. So let me go over the basic API calls that you're going to use with OpenTelemetry tracing. So it's pretty straightforward. You're going to just, from OpenTelemetry, import the trace package. And here I'm just looking at a controller for my hello world route. And at any given point, you can get the current span out of the context. So just by calling get current span, if there is a current span running, this will pull it back out for you. And since Flask is automatically instrumented, there's automatically a current span available. The most basic thing you can do is add attributes to this span. So if I just want to set a new one here, let's say foo is bar. On my server again. Oops, sorry. Server. Run the client. Go. And look back here in Lightstep. New spans coming in, and I can see foobar is now available as an attribute. And then I can find all of the other spans where bar was set to foo. There's only one because I only did one request. So the first thing you're going to want to do when you start improving beyond the instrumentation that's already installed is to start adding your own application-specific attributes to these spans. So I want to emphasize, you don't have to go around creating your own spans. The instrumentation should provide you a span already. You just want to continue to decorate those spans with your own attributes. The other thing you can add to a span is an event. And you can also chain these things. So if I'm going to chain adding event, do it this way. Events are basically logs, right? So I want to say the log message here is hello world, but then I can also add attributes to this log. So, you know, key value. So let's restart my server here and have a look at that information. Ooh, and I got a problem. Let's see what it is. Object has no attribute at event. Derp. Maybe we can't actually chain them in Python. You can see how quick I was able to find that error. Okay, things are good again. And if I look on this span, you can see a log event has shown up. Really don't like the way Lightstep shows these logs. I want us to improve this, but you can see I've got hello world and then the keys and values attached to that. So that's basically the way you can add logging onto your traces. But of course, there's special kinds of events which are exceptions. We've got a good example of them here. So any kind of uncaught exception will automatically get added as an event, and it will set the span into an error state. So it sets the status of the span to error. This means this span will start counting against your error budget. It'll cause alerts to go off because your system is aware that it's actually an error. And you can do some of this yourself. So just to walk through the remaining API calls, we just showed you how to set an attribute so that you can index your spans. We showed you how to add events to your spans to do logging. You can also record an exception. So record exception is just a wrapper around add event that properly formats the exception. So if you're actually trying to record an exception, use record exception instead of add event. And last but not least, you may want to start your own child spans. So if you're instrumenting, say, an in-house framework, or you have important operations that you want to have timing information on, you can create child spans in order to do that. And that's simple enough. Again, you just grab, actually, no, let me back up a second. If you want to create spans as opposed to just getting the current span, you'll need to create a handle on a tracer. So when you go to the trace library, you just create a tracer by calling get tracer. And by default, you just want to name it after the package that you're in. And what this does is it allows you to track back where the spans are actually getting created from. So for example, here, I can see that this span here came from the request instrumentation. This span here came from the Flask instrumentation. And if we look at a system that doesn't have an error, like this server span here, you can see that this came from main. So naming a tracer is the way to actually track back to what particular package was creating the span. So basically, all you have to do is, at the package level, create a tracer. Once you have a tracer, then you can just say start as current span, name the span whatever you want, you know. And then from in this with block, this span will now be set to current. So here, you know, you can access it directly as the span variable, but let's say you're buried several functions in deep. You don't have to pass this span around. Instead, you can just call current span from within this block. So within this block, the current span is now going to be my special operation instead of the parent span generated by Django. So if I just do this, say, set an attribute. Reboot my system. Okay, so we're just running my server again. Make a call to my client. So now we see my special operation is the new name for this child span. And then on this, we can see the attribute that I've added. And so that's the basic pattern. OpenTelemetry might look complicated when you see the system because there's just a lot of moving parts. But as an application developer, when you go to actually use it, this is all you really need to know. You need to know just how to set OpenTelemetry up, add the instrumentation plugins that you need, and then configure the SDK. Then within your application, when you want to instrument it, you just need to know to get the current span, set attributes in order to add indexes to it, add events to log, record your exceptions, and then create a child span in the event that you might need to parse out the timing information for a particular operation. And that's literally it. That's all you need to know about tracing in OpenTelemetry. And all of this is available in this sample app. So you can go try this out yourself. All right. So that was the code walkthrough. I'm going to stop here again and ask if people have any questions. No questions? It all just made perfect sense? Okay. Well, again, you can continue to ask questions through the chat. I do want to move on just to make sure that we have some time to go over just some pointers around setting this up within your organization, because I know someone was asking about that. So, how to actually roll out OpenTelemetry in your org. This can be a little bit trickier than rolling out just like a APM tool or logging or monitoring tool, because it's distributed. So distributed tracing only really provides value if you have it installed in every service. So it's important when you roll this out, you roll it out everywhere. Unfortunately, rolling it out everywhere might be difficult. It depends on how your organization works. If your organization has some centralized place where you can install and deploy OpenTelemetry, maybe you have an infrastructure team or your deployment tool lets you install this, or you're using enough of like shared frameworks and shared infrastructure, there's one place you can put it so that all of your services will roll out with OpenTelemetry installed and configured, then great. I recommend absolutely doing it that way if that's available to you. However, for a lot of orgs that may not actually be the case, it may be more like you have a bunch of services, different services have different teams working on them, and there isn't one centralized place to go and install OpenTelemetry. In that case, you need to go around to these different teams and get them to do it. One thing that can make this easier to do is to have a goal. So what I recommend doing is picking a particular transaction that's important to the organization. Maybe it's like the checkout transaction on a web store, or a transaction that you just know has problems and you'd like to investigate. Maybe there's a particular transaction that's slow and you've had trouble to figuring out how to actually debug it, or a transaction you've been seeing a lot of errors around. One way or the other, finding a transaction that people can agree has some value in being able to observe it. Then you can go to just the services that are necessary in order to observe that transaction. So you can go to those service teams and say, hey, I'm trying to observe this particular transaction. Can we install OpenTelemetry so that I can have a look at it through tracing? Then when you do that, just try to get the bare bones default instrumentation installed if you can. There's not necessarily a need to go in the first pass and decorate it with a lot of additional information. You just want to make sure that you're getting an end-to-end trace going around something that has value. because once people can then see the value, once you have a distributed trace, then it becomes easier to say expand it out within your organization. So once you've got that going, you can then say, hey, wow, look, there's a lot of value. We were able to solve a particular problem. We should add this everywhere. And that'll be a little bit easier on the other side of being able to show people actual traces so they can kind of get their hands dirty and understand what the value actually looks like. The way that I have seen this go wrong is an engineer is excited about tracing. So they're kind of championing and they want this to happen. But they don't have a mechanism for making it happen because they're just an engineer. So they kind of go around from group to group, from service to service, and ask people, please, could you install this? And maybe some services do, maybe some don't, but the end result is kind of an inconsistent layout. And that means you don't have complete traces. So the value doesn't look all that great. And then it kind of peters out. So that's really, if you find yourself that you're in a situation like that, that's where, again, figuring out some kind of high value transaction to target. And then potentially trying to find like a project manager or someone in management who's maybe used to going across teams and making these kinds of requests. You can get someone like that on your side. That will make it a little bit easier to have a more organized rollout. So I definitely recommend, taking that business value that you want to get out of it, pitching it to a manager and having them help you talk to the other teams if it looks like it's not an easy sell just to do it on your own. It can also be really helpful to create documentation and resources for people. We've got our OpenTelemetry docs, but they're of course not specific to your organization and your services. So just creating some documentation that makes it easy for people to add it to services in your application can be really helpful. It can also sometimes be helpful to wrap OpenTelemetry up in some helper libraries. I recommend as much as possible putting this tracing information in your framework code rather than in your application code. So if there's places you can put it that kind of gets it out of the application developer's hair, that can really help. And like I mentioned before, coming up with your own standard names and conventions for application-specific information can be helpful. And that creating a place where other teams, as they start to add their own information, their own conventions, can add that information to a document. That then means when you're looking around and looking for information, you have a list of all the different keywords you could search by. And that can be really helpful when people are trying to figure out where to get started and what kind of queries they want to make. Cool. So that's kind of my pitch on how to get started within your organization. We also at Lightstep offer kind of like quick start consultation. I just want to throw this out there. If it is more just like actually getting hands on keyboard and getting this set up, if it seems like it's hard to do or you don't have the resources, besides like Lightstep as a product, I'm not trying to sell that right now, though you should check it out. Totally separate from that, we're interested in doing just direct engagements with people, specifically just to help them set up OpenTelemetry. So you don't have to use Lightstep to use this service. It's just a way to get some of our engineers helping you to actually stand it up if that looks like it's been difficult. So you can contact support@lightstep.com if that's something that's interesting to your organization. And I'll leave you with that. If you have follow-up questions, come here, you. We run a Discord server, so you can find us hanging out there. In addition to the OpenTelemetry Gitter channels, if you want to talk to me or other people at Lightstep about OpenTelemetry, our Discord's a good place to ask questions. My friend Austin Parker runs that, and he's a super helpful guy. And that's all I got. Oh yeah, you can also ping me afterwards on Twitter. So that's me on Twitter. And so my DMs are open and you can send me questions there. And that's all I got. Any final questions at the end before we sign off here? Ah, see, Eduard's got a question.
Hello, I have put my question in the Q&A section.
Oh, there's a Q&A section. Oh, hey, sorry, I didn't have that window popped up on my screen. Yeah, is it easy enough to add some decorators to a particular method so it'll automatically create a span on each call, eventually adding a subset of its parameters as attributes? Yes, I know in Java they have annotations. I'm not sure if Python has a similar mechanism, but it should be straightforward to do. You can see like a span uses a width wrapper. So if you're using a framework that has like lifecycle hooks and things like that, that's a good place to put this stuff. But sorry, yeah, I don't know Python well enough to give like specific advice about how you would add like an annotation to do that for you. So.
Thank you. I will search for it.
Great. Yeah. If we don't have that as an option yet, and it is possible to do, that would be a great thing to contribute back to OpenTelemetry. I should throw that out there as well. The core team's mostly been focused on just getting the SDK and API production ready so that we can announce a 1.0 and make it stable and provide stability guarantees. And once we've got that under our belt, we'll be switching more to, adding kind of this kind of value on top of it, adding more instrumentation, more helper methods and things of that nature. And by the way, you should actually look for a 1.0 announcement coming out next week. The specification just turned 1.0 today, and we have release candidates coming out. So it's a good time to check OpenTelemetry out and provide us some feedback. All right, well, hope that was helpful to you all. This video will roll out on YouTube and you'll get a link to it in your email. So if you did miss something, you can come back and look at it. And again, you can check out that Python basics repo that I gave you access to if you just want a good place to kind of copy and paste stuff out of. So hope you enjoyed it. I'll see you on the internet.